many companies and also their employees, they are asking at the moment the question, how can we reduce costs? One of my clients came to me and asked me to create a keynote for their solution architects on how to reduce costs. So the question was, what can they do to reduce costs? And this is the keynote that I have delivered, and I will deliver that now to you. Let's dive in continuously delivering value while reducing costs. So, what do you think? What is the percentage of features in an average software product that are rarely or never used? I give you some time to think about that. Yeah, maybe. Let's have a look what the answer is. The answer is 80% of the features in an average software product is rarely or never used. And this number is just mind-blowing. And there are different studies out there. I linked one of the studies which showed that in there. So let's keep that in mind and go to the next question. And the next question is, what do you think? What is the percentage of total software lifecycle costs in a typical attributed maintenance activity? So when you look at a feature, let's say that feature costs $100, what percentage of these $100 do I need over the whole life cycle of that feature, perhaps over the next 5 years, as long as this software lives? I give you also some time to think about that. Yeah, maybe. Sounds a little bit high, a little bit low. Let's dive in. There are different studies out there which have looked at the software lifecycle costs of the maintenance. And when you look at the summary of all of that, then you could see that it is 40 to 80% of the costs that the feature costs in development, which you need for the whole life cycle throughout the maintenance of that feature. Now we have these two things. So first of all, 80% of the features of an average software are rarely or never used, and the maintenance costs of all of the features cost additional 40 to 80%. Now, with this information, we can go in and make a rule of thumb calculation. In Swiss German, we call it Milchbüchli-Rechnung. So let's assume that we have 10 features which get developed. The costs per feature are 100,000 Swiss franc, and the total development costs is 1 million Swiss franc. So the maintenance costs, you remember, it's 40 to 80% of that is roughly 400,000 to 800,000 Swiss franc. So with that, we can calculate the total costs of these features, which is a minimal total cost of 1.4 million Swiss franc and the maximum cost of 1.8 million Swiss franc. Please note, usually the business only looks at the development costs, so at these 1 million that the features cost, and usually it gets completely forgotten that you also need to maintain. Usually it is because this is another team, another cost point. This can be OPEX costs and not CAPEX costs. All of that plays into that. But when we want to reduce costs as a company, then it's important to know how these things work. So Now, we said that 80% of the features are rarely used. So we have potential savings in development of 800,000 Swiss francs and potential savings in maintenance costs of an additional 320 to 640,000 Swiss francs. This gives us a total saving of a minimum of 1.1 million Swiss franc or 1.4 million Swiss franc. Of course, many of you will now say that are mathematically skilled, this is of course very obvious. Yes, it is very obvious, but having these numbers is quite an important thing, and also making these a rule of thumb calculations. Now, what I want to point out, and this will also be a theme during this presentation, is over there, these total costs of 1.4 and 1.8 million Swiss franc is all about building the thing right. So it's all about software engineering, of doing it right, of quality. So when we are doing a good job, then it's more in the direction of 1.4 million. If we are doing a bad job, then it's more in the direction of 1.8 million. So there we already have quite some interesting cost saving. But there is another thing, and this is building the right thing. So if we can avoid building features that nobody uses, then this is even a larger cost saving that we can do, because we don't need to build that feature and we don't have the maintenance cost, the additional maintenance cost of that feature. Because I don't know what you think, but I have never seen that a feature that has never been used has been removed from a software, which means we will pay the maintenance costs. So building the right thing right, this is a very important thing to do. And Dr. Russell Ackoff has created that beautiful sentence where he said, doing the wrong thing right is not nearly as good as doing the right thing wrong. Absolutely beautiful said, he really nailed it. Now, first of all, we need to understand building the right thing, that is all about aligning our solutions to the business, to the user needs. So really understanding the problem that we need to solve for the user, the behavior change, all of that. So having a common understanding and building the right thing. This is all about effectiveness. And building the thing right, this is all about software engineering practices. How fast can we deliver? How easy can we change things? And this is all about efficiency. And it is important to understand these two things, and we are only successful when we are building the right thing right. So you might say, hey, this is all not my fault. The business have ordered that. They said we need to implement that. And I always say, if you run with the crowd, you share the blame. Or in Swiss German, mitgegangen, mitgefangen. The important thing here is, it is your company. And when you can avoid that features are built which are not or rarely used, then this will have in the end an impact on the revenue, and with that it will have an impact on your bonus or on your wages. And that's an important thing to consider. So it is your company, you are working for that company, and therefore you should also care about the features which are rarely or not used. So I want to dive a little bit deeper into that problem, where this whole problem is coming from. And when we look at projects, or software projects, then in the past we used the Waterfall the Waterfall methodology to doing projects. We planned, designed, developed, deployed, and reviewed, tested, and launched large chunks of software. Nowadays, some of the companies are still doing that, but in the year 2000, some bright people came together and they said, this is not how we can do software engineering or software projects. We need to go into the direction of Agile. So traditional Waterfall, scope, budget, and time of these projects are fixed. And in the Agile, time, budget, and scope should be not fixed. So the scope is variable. And the thing is, in most of the times, this is unfortunately not true with the scope. And you already see the problem that we have is that we are still using projects instead of products. In the end, when we are building a software, this is a product or a service in a company which we are selling. And it should not be a project, because a project has a start and an end. It has a set of features, these 10 features that get delivered for that amount of money. That's output. So a project always maximizes the number of stuff that gets produced. These 10 features, it's all about features, user stories, tasks. So delivering what is ordered. On the other hand, a product focuses on the outcome. We want to deliver that one feature which solves the problem of the customer. So, or changes the behavior of the customer. And that's an important thing to remember. And this is part of the problem that we are facing in many companies. So we should go away from these projects with fixed deliveries to more of the product thinking, where we say, okay, what kind of problem do we want to solve? And not delivering these 10 stupid features where only 2 of these features are then used by the customer. So when we look at that, many people in companies think it looks like this. We have all beautiful ideas and then we develop that and then something very awesome comes out. And especially nowadays with AI and AI agents, we think, oh, everywhere there needs to be an AI agent. And yeah, we will develop that and stuff comes out. And this is exactly the problem. It actually looks like this. We have, unfortunately, many not so good ideas and only some good ideas. And in the end, we have an okay-ish solution. Now, what is the solution for that? The solution is to use the lean startup cycle from Eric Ries, where you say, okay, we acknowledge that we have many ideas and we go in and build an MVP. And I don't mean the minimal viable project. I really mean an MVP which allow us to prove the hypothesis. And you see that there. Because only then, when we prove the hypothesis, we can decide whether we want to continue or we want to stop. What I always recommend, and I like that quite much from SAFe, this hypothesis statement that you can see here, which you can use for ideas or initiatives or also epics. So what they have created is that form, and I like very much this elevator pitch that you see there, where you say for customer who does something, the solution is something, so the why, that provides this value, unlike competitor, current solution, or non-existing solution. Our solution does something better, and this is sort of the why. This epic description is very, very good, and I can really recommend to use that. You will see when you are talking with business about their ideas, or also when you have an idea and you cannot fill out this thing, then it might be not so a good idea. And this is also true when you are talking with business people. Now, the business outcome, this is a measurable benefit. Usually you have that with sort of a return on investment or with the business case that lies behind that idea. And then there is the leading indicator. And they are very, very beautiful, because there we say what are the leading measurements, the early measurements which we can do to verify if this hypothesis is true. This is a very, very important thing to do and also to write down. And then we have a set of non-functional requirements. I give you a quick example so that you see how that works. This is really a very, very simple example. I made it as simple as possible so that you have an understanding how that goes. So we have in Switzerland, and this is not true, we have sort of a company which is Swiss Dentists. They have a CEO, this is Dr. Hans Muster, and he wants to have a mobile app for his company, the Swiss Dentists. So we create together with him this elevator pitch, which goes like this: for Swiss Dentist customer who want to schedule a dentist appointment, the Swiss Dentist app is a mobile application that provides the ability to schedule appointments, reschedule appointments, and search for location. Unlike AA Dentists, which is the other company, our solution keeps our customers informed with automatic notifications. The business outcome is majority of the appointments scheduled are done via app. Call center volumes decreased, so this is the business case. So we want to automate things so that we have less costs. This is a cost case. Better customer experience with the app so that we get more people. So the leading indicators is less call center activity regarding scheduling of appointments and increased overall appointments because of automatic notification. And of course, we have a set of non-functional requirements. So I just read through that. You already know what we need to do and what sort of the idea is behind that. And that's the beauty of this epic hypothesis statement. So use that for your idea to formulate these ideas. Now we are going in, and what we are doing in that case is we are not creating a first web page, we are creating a paper prototype, and with that paper prototype we are going into some of the branches of Swiss Dentist, and we are interviewing the people there. We say, hey, look, we have that beautiful app which you can download from the store. And the feedback, they didn't even go into sort of the prototype. The feedback of the customers is, we don't want another app. I don't want to download another app. I have so many apps, I cannot find any apps. So we are a little bit like, okay. And then we think about, okay, what about if this would be a web page? And they are saying, hey, if it's a web page, I would go to that web page. Aha. So the hypothesis is disproven. We can pivot and do a new one. So the new one is a web application, because we learned that a mobile application is not so good for these customers and they want to have a web application. So again, we are now going with paper prototypes to them and showing them the web application, and they are saying, oh, okay, that's cool. And they are scheduling the appointments on the paper prototype. With that, we say, okay, now we can develop a web page, and we make a very, very simple MVP web page. And with that, we are going to 100 customers and seeing if they are going to schedule appointments. If the leading indicators that we show are true and the call center activities are going down with these 100 customers, then we are building more and more, scaling that up. So this is the lean startup cycle that you can also use, and also this epic hypothesis statement. Very, very important. Don't start with the technology and work your way back to the customer problem. Start with the customer and the problem to solve. Nowadays, I see quite often with AI, everyone is saying, oh, now we have AI and we need to have an AI agent. This is technology. Don't start with the technology. Start with the problem that you want to solve. And here, this is a very important concept which you always should have in mind. Go focus on the outcome, the problem that you want to solve, the new possibilities you want to build. This generates the impact, the bottom line, the net result of your organization. And of course, you need to have output. These features, they are generating the outcome, but the focus should always lie on the outcome. This is important. So next, how can you make cost-effective decisions? I mean, when you look at there, usually when you want to try to solve a problem of a customer, then there is a whole problem space and you need to pick the right solution. How do you do that? And there is a beautiful technique that I use nearly on a weekly basis, and it's very, very simple, and you can do that on a whiteboard, on a Miro board, everywhere. It is called the Multiple Criteria Decision Analysis, MCDA technology. Some of you might know ATOM, the Architecture Trade-off Analysis. This is in fact part of ATOM. A very, very cool technique. And it's really, really simple. You see the key steps of MCDA down there on the left side, and I will go now with you through this technique step by step. So first, we need to define the objective. In our case, and it's again, very simple example, we need to identify the best fit architecture. So what kind of architecture style should we use? Very, very simple example. Okay, we defined now the objective, and now we need to define the criteria. In our case, because this is a presentation about cost effectiveness, cost effectiveness is one of the criteria. Scalability, maintainability, complexity, deployment speed are the other criteria. Okay? Now we are going to say, okay, what are the weights of these criteria? And of course, cost effectiveness has the highest weight with 30%, scalability 20%, maintainability 20%, complexity 20%, and deployment speed 10%. Okay, now we are listing the options. The options of architectural styles are monolith, SOA, microservice, and serverless. And of course, I know there are more architectural styles out there, but for simplicity, this is what we have chosen. Now we are going to rate these options, and this is just over the some ratings that I gave them. It is not meant to be accurate, and it's also not my opinion. Just for example. So what I used here is a rating from 1 to 5. You can also go from 0 to 10. You can also use minus, 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 0, plus, plus, plus. I don't care. You can use whatever you want. In the end, you just need to calculate. And this is sort of the next step. You calculate all of these numbers. You see the total of these numbers. And then you also calculate it with the weight that we are having there. And the weighted total is also there where we look at. And we can clearly see that in that case, serverless has the highest rating. So this is sort of what we should choose. Now, you can also say, no, I want to have a monolith. This is completely okay. But then you see also where we have lower ratings. And in that case, you need to mitigate these lower ratings. And this is sort of the last step. Now, in the case of serverless, we would need to mitigate maintainability and complexity. And these would be sort of the example mitigations. So for you, what is very important, there is no silver bullet out there. There is only a solution space out there with options, and these options require mitigations because they will always have some disadvantages. That's the important thing. Now, to the last part, where we are going into more of the socio-technical system. So the question is always, how can I identify and reduce waste and thereby lowering the overall costs of development process? And here it is important that you understand that any organization you are in, be that a team or even the whole company, this is a socio-technical system. And a socio-technical system always contains the processes, the technology, and the organization, the people. And they need to work together like a digital factory or like a machine. And this is a socio-technical system. And this system needs to be very well maintained, and it needs to continuously deliver value. So in that, one of the essential skills, especially in the age of AI, when it comes to socio-technical systems, is that whole system thinking. Of course, you can focus only on the development team and improve the development team. But the problem is what comes after the development team. Usually sort of testing and deployment and operation. So if you only focus on that and improve that, then it will stress the other steps in your whole value stream. And this is the important thing. You need to look at the whole system and you need to look at the whole value stream. Now, what is a value stream? A value stream is a sequence of steps that deliver value to the customer. It's step 1, step 2, step 3. In the beginning, it has a trigger, which triggers that value stream, and in the end, you have value that gets delivered, and you continuously do that. So the trigger can be a customer that purchases something, and in the end, you have value. The important thing is there are different value streams. There is the operational value stream on top, and there are the development value streams here in blue. So the operational value streams in violet there, they are always starting with the customer and it ends with the customer. You see there one of these operational value streams, here a loan application, and you see the steps. Customer acquisition at the start, then initial proposal, a loan application, application review, payment modalities, contract conclusion, loan distribution, repayment, and contract end. These steps, this operational value stream is supported by systems. And these systems are built by development value streams. They support these operational value streams. And that's an important part that you need to understand. So now, what is a development value stream? A development value stream also has a trigger, and then you have define, build, and validate and release sort of as some steps, and then you have a new increment that comes out, and this is the development value stream. It can also be a bug request. So when we look at why we are mapping the development value stream, then this is all about understanding how value flows through the system, measure the organizational effectiveness, identify the bottlenecks, and also improve the whole value stream. That's what the important part of that is. So, and you see, it is also important because we really want to improve the whole value stream and have that whole system sync. So what do you need to do value stream mapping? You bring all the people that work on a value stream into a room. It includes also the management. You identify the steps, so feature definition, design, code, test, and then you identify the people who are responsible for these steps, like the PM, the architect, or the developer, or the tester. And when you have done that, then you calculate the metrics. Here you see some of these metrics that we have calculated. The PT is the process time, LT is the lead time, and percentage complete and accuracy, the percentage C&A. This is the percentage C&A, sorry for that. So process time is the time where we are really doing value added work. So where we are really focusing on doing stuff. Like, for example, in coding, this is where we are concentrating and coding. Not where we have meetings or anything else, which is also around that. The lead time is the time from the last step to the end of that step. So from end of design to end of coding. And the percentage complete and accuracy is the time, the percentage complete and accuracy is the percentage in which the next step can use the result from code, for example, as is. If we need to go back because there was a bug, then it will be lowered. So in code, it's 60%, which means in 40% of the time, we need to go back. We have also the total PT, which is the sum of all PTs, the total LT, which is the sum of all LTs, and we have the activity ratio, which is total PT divided by total LT, and then we have the rolled percentage complete and accuracy, which is the multiplication of all these percentage complete and accuracy that you see in there. So now, what do we see with these numbers? So we see the total PT, which is 161 hours, and the total LT, which is 2,160 hours. The total LT, this is the time to market. So from a feature definition or from a feature request until it is in production. The rolled percentage complete and accuracy of 5% says in 5% of the time, these 2,160 hours are true. We are going through that without any going back. In 95% of the time, the total lead time will be higher because we have some quality problems in there. And the activity ratio says we are focusing on work, so value-adding work in 7% of the time, and 93% of the time we have sort of waiting times in that system. So we now see quite some very interesting things, and we also see now the bottlenecks. For example, in test, we see a process time of 8 hours and a lead time of 336 hours. This there we should have a look at because there is quite a lot of waiting time. Only 8 hours of value-adding work and 336 hours where stuff is just lying around. 50% of C&A also is not good when it comes to testing. Also in coding, we have this problem. So we identified now the bottlenecks. Based on that, what we found out here, we can now go and say, okay, how can the future value stream look like? So in the future, how should it look like? And this can really be the guiding North Star. I just displayed here how that could look like with a lot of automation in place. And you see the numbers are speaking for themselves. Everything is increased. And this will be sort of the absolute top line. I just show you quickly the numbers, how they sort of develop. And you see this is quite astonishing. And when we now think about the time to market, you see, instead of waiting 2,160 hours for a new feature, in 5% of the times, this number will be true, and in 95% of the times, it even gets higher, versus 147 hours for a new feature that gets delivered in 76% of the time. The important thing here is, when you are creating features or when you are delivering value, as long as it is in development, no value has been generated. Only when things are in production and used by a customer, then value is generated. Before that, no value is generated. And having a faster time to market saves you quite a lot of money when you are a company, because you want to bring the developed features as fast as possible into production so that they can generate value for your company. That's the important thing. And this is a way how you can, in that case, also reduce your costs. Now, many of you will say, hey, but Romano, what about AI? AI can help us with that. As I said, yes, of course, AI can help you, but don't start with technology at first. Start with the problem. But because you are asking, of course, when you look at the whole value stream, there are possibilities where you can use AIs that can support that whole value stream so that you get more efficient in going through that value stream. But this is just showing you very, very quickly sort of what the potential is. Take it with care. Always think about what is the problem we want to solve. And also think about when you can reduce or remove a process step, then this is far better than replacing that process step with an AI. So also think about how can you improve a process by just changing it or even remove it. Replacing or fixing a broken process with AI is not as good as just removing it. So with that, every AI or even AI agent that you build will need maintenance. And therefore, these AIs also must be designed with maintenance in mind. You remember that 40 to 80% of the development costs will need to be spent during the whole life cycle of such an AI. So again, always start with the problem you want to solve and also find the simplest solution. And with that, we are at the summary. To continuously deliver value while reducing costs, it is important that you build the right thing right. Always have that in mind and use the lean startup cycle to identify the good ideas and remove the bad ideas. with technology, we can do nearly everything. It is so important that we identify what we really want to do, what brings value to our customers. And this is where focusing on outcome comes into play. We need to understand what the problem of the customer is and solve that problem of the customer, creating that one feature that solves the problem. When we when we look at the solution space, then we have always different options in the solution space. It is crucial that we use this MCDA technique to identify sort of the right solution and also identify the disadvantages of that solution. Every solution has disadvantages. We need to mitigate these disadvantages, and therefore there is no silver bullet. There is not that one solution. And to do that, we need value stream mapping. We always need to look at the whole system. We need to understand how value flows through our system, identify the bottlenecks, and work on these bottlenecks. And with that, as you can see, please focus on doing the right thing right. In today's world, with technology, we can achieve almost everything. However, true success lies not in technology itself, but in focusing on doing the right thing. This approach drives effectiveness and reduces costs. And this is how you can continuously deliver value while reducing costs. Thank you very much.